What else do we need to know about color? Well, certainly there's a lot to know about color. Entire books have been filled talking about color and discussing color perception and color application in data visualization. Now, there are three more things that I want to discuss in this course. The first one is the meaning of colors across cultures. Remember, I was saying choose colors according to the data you want to encode. If you encode fruits, use the color that these fruits have. If you encode trademarks, use the colors that these trademarks are having. However, if it becomes more complicated concepts, such as anger, authority, balance, beauty, and so on and so on, be aware that different cultures have different colors for these concepts. Consider, for example, death. Death is mapped black in some cultures, such as Western culture, Japanese, and Native American. However, in Hindu, in Chinese culture, death is actually white. And if you look at Southern American cultures, death can be associated with the color green. So be aware of these colors and the implication of colors if you work on a topic that might involve cultural perception or cultural contexts. How do we create and use color in our coding? There's a nice library called Chroma.js. Chroma.js is a JavaScript library, obviously, and it allows easy manipulation and creation of color. You can create color scales ranging from one value to the other one, as in the example below. This small mode is actually the color space that you use. Remember, we had been discussing that the interpolation that you do between two colors highly depends, or the result that you get when you interpolate between two colors highly depends on the color space you're doing this transformation in, this interpolation. You can also darken colors and saturate and so on and transform between these different values. So the take-home messages on this lecture on colors are: color is a complicated variable which is made of hue, lightness, and saturation. Now in visualization, we usually use all of them as individual visual variables: hue, lightness, and saturation. If you use them in combination, be very careful how they play out, because some hues are already more light than others, are lighter than others. So there are inferences. Try to use only one if you do visualization. Choose a color scale that actually fits your data. Remember our map where we apply different color scales to the same map, what different patterns and different implications these patterns bring. So choose a color scale that fits your data. Avoid the rainbow color map unless you have a good excuse and you have a good reason why you want to use it. But maybe you also want to show two different pictures, one on a sequential scale and one on a rainbow color scale if you really must use the rainbow color palette. Be also aware that in many scientific domains, the color scale, the rainbow color map, is widely used and can be tricky. Test your color palettes for color blindness. There are several tools to do that, but there are also some rules of thumb and predefined palettes. And remember, whatever increases the accessibility for some fraction of the population increases the overall accessibility of your visualization. So don't be afraid of the additional effort that you put into your visualization to get the color scales right, because it will benefit every one of your readers.